For Supplement A for Math 135, we've just finished watching some 130 videos, and now I'm going to do a little bit of review and then continue on to something new. So let's review. We look at critical numbers. Critical numbers. We find critical numbers when f prime of x equals 0. So let's get an example. If we have f of x equals x to the fourth minus 8x squared, to find the critical numbers, we're going to look for the derivative first. So taking the derivative of x to the fourth is 4x cubed. Taking the derivative of negative 8x squared, we have negative 16x. Now we're going to set that equal to 0. We're going to factor and solve. What they have in common is a 4 and an x, so we factor out a 4 and an x. 4x times what is 4x cubed? We need an x squared. 4x times what is negative 16x? We need to get a negative 4. And you can check. You can go ahead and 4x times x squared is this. 4x times negative 4 is this. Okay, we're going to continue with our factoring. We can see that we have a difference of two squares. So we have x plus 2, x minus 2. So we can see that x is going to equal 0, negative 2, and 2. Those are going to be our critical numbers. Okay? Critical numbers. All right. Now, critical points. Critical points is where we actually put our critical numbers into our original function. So we're going to put our critical point 0 into f of 0, into their function. And if we put zeros in there, we just get 0. So a critical point we have is 0, 0. So on the graph, we would plot 0, 0. Okay, next we put in our negative 2. So f of negative 2. We put a negative 2 into our 4, x to the fourth, and we put a negative 2 here. This is going to equal 16. This is going to equal negative 32. So we have negative 16. So our critical point for f of negative 2 is going to be negative 2 is our input and negative 16 is our output. All right, let's do one more. So our critical number is 2. We put it into our original equation to find out what our critical point is. And we're going to have the same thing, negative 16. And so we have 2 and negative 16. Oops. So these are our critical points. This is what we would put on our graph. Okay? All right, let's continue. We also looked at the first derivative test. So let's go over the first derivatives test. Okay? Now again, you've seen this, but I'm just going to do it quick. If we have a point C such that f of prime C equals 0, that means that we've got this tangent line. To the left of C, we're going to put a point A. To the right of C, we're going to put a point B, such that we have, this is f of A, f prime of A. We can see that the tangent line is increasing. It's going to be positive. So we say the derivative, which is the slope of that tangent line, is going to be greater than 0. And then here we have f of b, and we can see the f prime of b is going to be less than 0 because the slope of the tangent line is going to be negative. Okay, so we talked about the first derivative theorem. I'm going to shorthand it. First derivative theorem. And we said that 1, if f prime of x is greater than 0 on the interval AC. So on this interval from A to C, if we find some point x, that f prime of x is greater than 0, and f prime of x is less than 0 on CB. So here we have some f prime of x less than 0, say AB. Then we said f of C is a relative max. Okay, so that was the first derivative theorem. And going the other way, if we have f prime of x is less than 0 on AC and f prime of x is greater than 0 on CB, this is just a quick version, then f of c is a relative min. Okay, very good. We went over that earlier. So now we're going to go into something called the second derivative test. Okay, second derivative test. Okay, I'm going to slow down a bit. The second derivative test. Second derivative test. Now, what are we testing for? We're testing for relative extrema. So I'm going to go ahead and write that for relative extrema. Right, this is to find out if we have a max or a min. Okay, so here is the second derivative test. If f prime of c equals 0, all right, and f double prime c is greater than 0, then f of c has a relative minimum. Okay, what would that look like if we have a picture? All right, so here we look something like this. F prime of c, here's our c, f prime of c equals 0. All right, that's the slope of the tangent line equals 0. And if double prime of c is greater than 0, then f of c has a relative minimum. So this is f. This point right here is f of c, and we can see this is a relative minimum. Okay? Second one, if f prime of c equals 0 and f double prime c is less than 0, what do you think that's going to happen? You know what's going to happen, huh? F of c has a relative max. Okay, so now we're going the other way. It would look something like this. We still have this equals 0, f prime of c equals 0. Okay, then we have a relative max. Okay, now there is a third step to this one. If f double prime of c equals 0, okay, so now we have f double prime c greater than 0, relative min. F prime, double prime c less than 0, relative max. What if f double prime c equals 0? Then what we're supposed to do is use the first derivative test to determine what we have.